Welcome all of you in today's video lecture. In today's video lecture, we are going to learn one of the flow property of liquid, which is thixotropy. So before going to start that thixotropy, we need to understand what is the Newtonian and what is the non-Newtonian fluid. So thixotropy is one of the type of non-Newtonian fluid. So let's get started. So there are two types of flow. First is Newtonian system and second is non-Newtonian system. Newtonian system which obeys the Newton's law of flow. So this is the formula for the Newton's law of flow. F is equal to eta g. Okay. So second is non-Newtonian system. In non-Newtonian system, they are further divided into two types. First is time independent and time dependent. Okay. So time independent, in the time independent there are three subtypes. First is plastic, second is pseudoplastic, and third is dilatant flow. So in the time independent there are further two types. So first is thixotropy and second is negative thixotropy. So in today's lecture we are going to learn the first type of independent, time independent non-Newtonian flow, which is thixotropy. So just pause the video and take the screenshot. Okay, so thixotropy system is a shear thinning system, datum, okay, and on standing it is expected to recover its original consistency of the fluidity. Okay, so in thixotropy, however, it takes longer time to recover compared to the time taken for agitation. This behavior is called as thixotropy. So there are three steps by which we can understand the theory of thixotropy. So whatever the solution or the system at the beginning is, the consistency of that system at the beginning in the thixotropy is gel-like consistency. So after applying shear or after applying force, the contact between the molecules get dislocated. Okay, so it changes the consistency of our liquid in the second stage. Okay, so the gel-like consistency of our liquid get converted in a solution-like consistency. That means our solution have consistency as a homogeneous solution. Okay, so after that, the third at the rest, that means if we keep that sheared liquid aside for a while, it get recovered its original consistency of fluidity after some time. So it get its original gel-like consistency after for a while. Why it is happen? Because of cohesive force between the molecules of that system. At the beginning of the system, the molecules get attached with each other with covalent bonding with each other. Therefore, they behave like a gel-like consistency. The viscosity of that system is high in a first stage. Okay, at the rest. So after applying any shear, it dislocates the bonding between that particles between that system. Okay, therefore the contact get broken. After that, it consists a solution-like consistency, and at the end, if we set aside that solution, it regains its original consistency. So just pause the video and take the screenshot. So there are two types of consistency curve in the case of thixotropy. So we need to relate the thixotropy curve in the case of plastic flow and pseudoplastic flow. So as we know that the plastic flow does not start from the origin. Okay, so on the same way, in the case of thixotropy, the plastic flow does not start from the origin. Okay, so it starts from on the any point on the x-axis. Okay, so in the case of plastic thixotropy, when we apply shear stress at the beginning, the flow of liquid does not change. Okay, so after that, after particular shear stress, that the behavior of the flow get changed. That means the consistency of that liquid is decreased after applying a particular shear stress. If we are unable to apply that stage, that the flow of thixotropic plastic flow does not change. Okay, so the substance behaves like an elastic body that fails to change the flow when the less amount of stress is applied. Okay, so if we draw a plot against rate of shear against the shearing stress, if we plot rate of shear on y-axis and if we plot a shearing stress on f-axis, we will get a graph in this way. Okay, so this graph represents that whenever we apply a shear stress, it changes the consistency of liquid. Okay, so it starts from here. That means if our liquid is viscous in the beginning, whenever we stir that liquid or apply a shear stress, it started changing its consistency. Okay, that means the fluidity of that liquid get increased. Okay, after certain time, if we withdraw that shear stress, what will happen? After, if we keep that sheared liquid aside, it start gaining its original consistency or original fluidity. Okay, so it started gaining its original consistency in BC. Okay, BC represent the gaining of reconsistency of that liquid or gaining its original viscosity. Okay, so this is for plastic thixotropic system. In the second type, this is the pseudoplastic thixotropy system. The thixotropy pseudoplastic system, it starts from the origin. Okay, so it starts from here. So after that, if we apply a shear stress on that type of thixotropic system, it started changing its fluidity from the beginning. Okay, so what will happen? It started changing the viscosity. Why it's happened? Because there is a particular contact point between the molecules of thixotropic molecules. Okay, so for example, these are the molecules of thixotropic system. Okay, they have particular contacts. Okay, so they covalently bond with each other, and after sharing, what happens? The contacts between that particles get disturbed. Okay, so they remain separate in our system. So they just remain as a separate entity in our system. Therefore, the consistency of that liquid is disturbed. Okay, so the liquid behaves like solution. The gel-like consistency changes to the liquid solution-like consistency. But if we keep that sheared liquid for a while, what will happen? Because of Brownian motion, the particle move in our solution, throughout our solution. So they just, whenever they comes with each other, they start bonding with each other. Okay, so they just get their original consistency with that. Okay, so this is the mechanism of thixotropic system. Okay, so they get their original consistency whenever they kept aside for a while. Okay, in both the system. What is the difference between that? In first system, at the beginning when we apply shear stress, it does not changes the consistency of liquid, but after a while, when a particular amount of shear stress is applied, it started changing its consistency. But in pseudoplastic flow, from the beginning, it starts the changing its consistency. Okay, so this is the end of today's video. In today's video, we learn all about the thixotropy So if you like today's video, please hit the like button, and if you are new on my channel, you can watch my previous video by clicking on I button, and please subscribe my channel. Thanks.